Hello everyone, my name is Sean Schufert and I am a mechanical engineering technology student, and today I will be talking to you about testing in systems engineering. The topics of discussion for today will be what is testing, and I will be describing to you physically what is it that you are doing and also what the definition is. I will also be talking to you about the V-model diagram and how it works to develop a product. I will also be talking to you about 5 different types of testing. And last, I will be going over the flowchart of testing. I know it's hard to see this, so you might want to take a moment to stop and open up the PDF file that I've sent you to go over this with me. Actually, it's not a PDF file. It should be in a PowerPoint presentation. First, I'm going to just show you here what is a test. This is what I've found from the ENMA class 415. A procedure in which the performance of a product is measured under various conditions. Basically, what you're doing is you're going to take the prototype or product and test it either in its environment or in the lab and see what specifications are in relation to what the test values are and if they're within acceptable levels. Next is the V-model diagram. You're going to have, starting with the requirements of the design and the acceptance testing, and you're going to work your way around. And this is actually an example of software development. So you're going to start out with requirements, and then you're going to work your way down to general design specifications. And then from there you're going to go to detailed design specifications, and then you're going to go down to your source code. From there you're going to work your way back up to your unit testing, your component testing, and your acceptance testing. And what you want to do is as you have a problem here, your testing indicates that it's not within acceptable levels, then you work back over to here, which would be your detailed design specifications, and you want to change your detailed design specifications based on your unit testing, and you want to change your general design specifications based on your component testing, and then you want to change your requirements based on your acceptance testing. And the way you want to do this is you want to work from your top and work your way down and slowly get to the point where you're just working with your detailed design specifications until that you get what you want out of your source code. 5 types of testing. You're going to have analytical, and then you're going to have phase 1 through 4. 5 different types of testing. Starting with analytical. Analytical, you're going to consider the ability for the product to be integrated into the person's workspace ergonomically. You're also going to be considering looking at what the product is going to look like at the end of the project, or what the system is going to look like at the end of the project. And last, you're going to want to consider what's already out there on the market. You don't want to go redesigning the wheel. You don't want to spend a lot of time on systems that have already been produced, and it's just inefficient and it's a waste of money and time. Type 1, you're going to be testing components. You're going to do dynamic testing, bench testing, like breadboards, using oscilloscopes, using load testers to test strengths of materials. You're also going to do rapid prototyping, like three-dimensional printing. if you don't understand three-dimensional printing, basically it's a X, Y, and Z axis CNC machine, and instead of taking away material, you're producing material through an orifice at the top. Usually it's a low melting point plastic or a catalyst reactive plastic. Bench and service test models. I have an example here of bench and service test models. This would be considered a bench test, whether you have a predetermined height that you want to get to without the other three wheels coming off the ground. And service test would be actually going out in the unpredictable environment and testing the vehicle. Type 2, we're going to look at what is already available, as in the system in the whole. Not just individual pieces and parts of the system, but what systems are relative to this system. You're also going to be testing the functionality of the prototype or product or system and the initial product units that have been developed from the prototype. Type 3, you're going to be testing the product or system in the field as it's being sold to the customers. The first few customers or the first few people who are using this system, you're going to want to see how it's working out for them. You're also going to want to do you're going to want to make sure that this is performed not by people who already understand the system. You want to be able to give it to someone and have someone who doesn't understand it but is in the same field, and have them be able to easily work through it and understand the system or use the product. You're going to want to test this over a long period of time. You don't want to just go through over 1 week and say, okay, it works, because you're not going to have enough variables in 1 week to determine whether or not it works. Type 4, you're going to want to test the product or system in the real world applications. You're not going to want to go out on a sunny day and make absolutely sure that your satellite signal works. That's just, that doesn't make sense at all. You're going to want to make sure that it works in all conditions, whether it's raining, storming, nighttime, daytime, even the extremes of solar flares happening and interrupting signals. You're going to want to apply this to multiple different situations, is what I'm really trying to get at. You're going to want the end user to be doing the functioning of this product. You don't want to be the one out there running it exactly the way that it's supposed to be ran. You want them to interpret it and run it as interpreted by them to get the full effect of if the product is working correctly or not. Okay. Last is the flow chart, and it's a little difficult to see, so I'm going to try and zoom in on it, or you can pull it up from class. It's the flow chart that was in week 6 notes. And I'm going to zoom into the dry erase board here. So, when testing, what you're going to want to do is, you're going to start out with the conducted test. And then you're going to work your way down to the collected data. And from there, you're going to analyze the data that you got. And the important step between the conducted test and the analyzing of the data is to have standards for all of these. You don't want some people coming in with measurements in foot-pounds and a whole bunch of other people coming in with measurements in Newton meters, because it takes more time to analyze the data. Once analyzed and compared to the scope or the predetermined specifications of the project, you're going to determine whether or not you have a problem. If you have a problem, you're going to move to the rep. If you don't have a problem, you're going to move down to your documented results, and just make sure that you document that you've taken this test. If you do have a problem, you're going to go over and you're going to review the problem, and you're going to see if there's action needed. Usually there's action needed, because usually the problem isn't already being resolved, and you're going to use the corrective action. If not, you're just going to record the results. If there is corrective action needed, you're going to want to do the corrective action, make sure the corrective action is complete, and reconduct your test, collect your test data, analyze, check to see if the problem's solved or not. I hope that you've enjoyed my speech, and have a great afternoon.